Good afternoon. 14.1 is about acids and bases and their properties. So acids taste sour, but we don't taste them in a lab, of course. They turn blue litmus paper to red. Strong acids react with metals to release hydrogen gas. They bubble and give off hydrogen gas. They react with bases to produce salt and water, which is usually neutral. And that is a neutralization reaction. Acids conduct electrical current because they have ions or charged particles. To name acids, there's two different types. Binary acids, that's of course two. So we have hydrogen, H plus is what makes it an acid, and one other element like chloride, for example. Okay, so to name a binary acid where there's just two, you are going to use the prefix hydro, and only for binary. So if it's not just two elements, you don't put the hydro out in front. You change the change the ending to ic. So chloride would become chloric, and then you put the word acid. So H and Br is bromine, you're going to change it to bromic, hydrobromic acid. HI, hydro, remember only when it's just two elements like HBr, HI, or HF. Hydroiodic, iodic acid. HF would be hydrofluoric acid. Okay, and non-binary usually has three different elements, though it could have more than three. And for non-binary, if it has three different elements, like these examples down here, or more, it's usually a polyatomic anion that ends with either ate or ite, and you're going to change that ending. The ate changes to ic, and the ite changes to us. So carbonate, when that 2 negative charge is balanced by 2 hydrogen ions, becomes carbonic acid. Nitrate, when you add an H out in front, so it's H plus NO3 minus, you get nitric acid. Okay, you guys name these ones at home. Pause the video and write the names. Okay, so we need to recognize that the ClO3 minus was chlorate. When we add an H to the front of it, becomes chloric acid. No hydro, because this is not binary. Phosphate would be phosphic, except we add the OR back in, so it's phosphoric acid when you have phosphate with the hydrogens in front. ClO2 is chlorite. Since ClO3 was chlorate, this is chlorite. Chlorite, as an acid with an H out in front, is chlorous acid. And phosphite becomes phosphorus acid. Okay, we need to know the 7 strong acids from table 6 on page 548. I don't have that in front of me, so we will write out the ones that are on the top of my head. HCl is a very common strong acid. That's hydrochloric acid, it's pool acid, and it's also called muriatic acid. We have H2SO4, sulfuric acid, which is battery acid. Another strong acid is nitric acid, HNO3. And then we have, this is this is hydrochloric. Chloric acid, HClO3, perchloric, there we go, and chloric. Okay, perchloric, because this was perchlorate, and we added the H, so perchloric, and then hydrochloric. That is 6, and the one that I am not thinking of, I believe, is HI. This one we're unsure of. I'll have to check. Okay, these are the 2 most common that you will see, and this one would be the 3rd most common. Okay, so some common acids. Sulfuric acid, I already said, is found in batteries. This is car battery acid. It's in all of these other things as well. Nitric acid is used in plastics, pharmaceuticals, and explosives. Phosphoric acid, that's what's in Coca-Cola and Pepsi soda to give it kind of a sour taste to balance out all the sugar. Hydrochloric acid, muriatic acid, it's used to maintain the pH of pools. It's also found in your stomach. This is stomach acid that helps us digest our food. Acetic acid is vinegar, and this is the one that we use probably the most frequently because it is not a strong acid, so it does not harm us when spilled, and it's much easier to clean up. It's also found in foods to make plastics and in fungicide. Bases. Bases are basically the opposite of acids. They taste bitter. Okay, if you've ever tasted baking soda on its own, it is not tasty. It has a bitter taste to it, and that is a base. They change red litmus paper to blue. This one's easy to remember because bases turn blue. So if you remember bases turn blue, acids are the opposite. They're going to turn red. They feel slippery. If you've ever gotten laundry detergent on your fingers before, that slippery feeling is the feeling of a base. They react with acids to produce water and salt. So that is the same. If you put an acid and a base together, they will neutralize, you get water, and then the salt from the other ions that were involved. And bases also must contain ions because they also conduct electricity. Okay. Some common strong bases are lithium hydroxide, LiOH, sodium hydroxide, potassium hydroxide, and calcium hydroxide. These two in particular, sodium hydroxide is also known as lye, and it's what's found in Drano and Nair because it will dissolve hair when you add it. Okay, so Arrhenius acids and bases. The Arrhenius definition is the easiest one. It's the most important for us. We will learn the other ones, especially in AP Chem. But for now, all you need to really remember is that if it's an acid, it gives off H+. If it's a base, it gives off OH-. Okay? But there's an important note here. Not everything with H is an acid. So a good example, H2O, not an acid. And not everything with an OH is a base. If it has an OH that is covalently bonded, that will not separate when it's in solution, it can be an alcohol. And that is not going to be basic because the OH does not come off. So it doesn't increase the OH in solution. It stays attached covalently to those other atoms. NH3, you might think, well, this might be a strong acid because there are 3 hydrogen ions, but NH3 is actually a base, and it has to do with its Lewis structure. CH3OH is another example of one of those alcohols that I was talking about. So this OH, the O, is covalently bonded to the carbon, and it will not come apart. This is methanol. Okay? A strong acid ionizes completely. So HCl is a very common strong acid. When you put it in water, okay, you mix the two together, it is going to ionize completely. So if I put 1,000,000 HCl molecules into water, I will get 1,000,000 Cl- ions and 1,000,000 of these H+ ions out. Okay, and of course we're dealing with numbers much bigger than millions because these are little tiny atoms. But they will all completely separate out. So the little H+, that's our H+, and the bigger Cl- will always separate. Okay, this is plus, this is minus. A weak acid, excuse me, a weak acid releases only some of the hydrogen ions. It partially dissociates. So if I put in, I'm going to lower the numbers down. So if I put 100 of these in, about 5% of a weak acid is going to ionize. That's a very rough number and it changes based on the acid, but about 5%. So that means that I would get how much H+ out of that? 5. If I put in 100, only 5 of them will come off, and that leaves me, so I have CH3COO- acetate, and the H+, which makes it acetic acid. I will get 5 of these. That means I have 95 molecules that will stay attached at any time. Okay, so only 5 of them come off. So when I compare these, let's say it was 100. If I put in the same number, 100 HCl's and 100 acetates, I will get 100 H+ out up here and only 5 down here. So if I get HCl on my hand, there's a lot of hydrogen ions that are what's going to do the damage to your hand. Down here, there's only 5. So that's why weak acids are not as harmful. Now we can change concentrations, and that's going to change those ratios as well. Neutralization is just where you mix an acid and a base and it becomes a neutral solution. So if I have, this is something we need to talk about, hydronium ions. H plus, we said, is what makes something an acid. H plus makes something an acid. H plus is not a stable ion. Okay, it's reactive. And when we have H plus, it's almost always in water, so we have billions and billions of water molecules all around it. It's going to approach one of these water molecules, and we know water is very polar. This is positively charged. It's completely charged. These negative electrons are very attractive, so it's going to stick to the water, and it's going to form something called hydronium, H3O+. That H plus attaches itself, and you get H3O+. That always happens. H plus by itself will not be present in water. It's going to stick. But H plus is a lot easier to work with than H3O+. So we will use both H plus and H3O+. They are always present in equal amounts, so they are interchangeable. Okay, so when you see H plus, I want you to think H3O+. Your book will always use H3O+ because it's more proper. All right, so when I mix H3O+ or H plus and OH minus, the acid and the base, I'm going to get water. The two will neutralize. This one is easier to visualize with the hydrogen ion. So when I mix these two things together, I get OH minus and H plus. These are oppositely charged. They're going to attract from Coulomb's law, and I'm going to get H2O. If I had H3O plus, which I do in water, that extra hydrogen that attached itself and the OH that is lacking, this is going to have electrons all around it. It's lacking that hydrogen. That hydrogen that's on the H3O plus is going to go over, and you'll get H2O and H2O, so you'll get 2 waters. So this is what's actually going on. This is a simplified version. Okay. Salt just means an ionic compound. That's a reminder for us that a salt is an ionic compound. It's formed when a cation and an anion join because of their opposite charges. Okay, so the force, the electromagnetic force, pulls them together, and you get a salt, an ionic compound. Okay, so this is our strong acid and our strong base coming together. The H plus from the HCl and the OH minus will make water. The Na and the Cl that are left over will make sodium chloride, table salt. What is going to form down here? Pause the video and write your products down. This is a double displacement reaction. Okay, so the H plus and the OH minus are going to come together and make H2O, but I have 2 OHs, so I will need 2 of these, and 2 H pluses and 2 OHs will give us 2 waters. What's the salt that forms? I have Mg plus from the base, Mg2 plus, because there's 2 hydroxides, it's 2 plus, and it's in group 2. And Br, which is a halogen, it's just 1 minus, so I need 2 of them to balance the charges. Okay, thank you guys. I hope you're having a wonderful day. I miss you all.